screen. There we go. So this is being recorded. Let's just make that whole screen if I can. Oh, just a bit slow. Need a magic wand. It's going to buffer now. So maybe I'll stop it and I'll start again. I think it's my PowerPoint. Oh, right. Okay. So, right. Okay, can you see that okay? Right. So sorry about that delay. Okay, I think we're just going to leave it as it is rather than make it full screen because it, for some reason, it doesn't want to do that. So in this session, we're going to consider what will my child learn about, how does my child learn maths at Castlemead School, and how can I support my child to be successful at maths? And we're going to start with the national curriculum aims. So those are to become fluent in the fundamentals of mathematics, to reason mathematically and to solve problems. And you can see that that corresponds with the diagram on the right-hand side. Normally when many adults think about maths, they're thinking about the computational and the procedural skills, so the actual working it out part, but actually maths is much more than that, and includes the conceptual understanding, which is the understanding that goes on behind that computation and procedure, which enables a child to understand what it is that they're doing with numbers, as well as the problem solving aspect where they're applying the computation and procedural skills and practicing using them with things they're familiar with and also with unfamiliar problems. Okay, so the curriculum for lower Key Stage 2 for years 3 and 4, the principal focus there is to ensure that pupils become increasingly fluent with whole numbers and the 4 operations. So that means addition, subtraction, multiplication and division, including number facts and the concept of place value, so the value of each of the digits in a number. And with that level of understanding, they should ensure that pupils develop efficient written and mental methods and be able to perform calculations accurately with increasingly large numbers. So at this stage, pupils should develop their ability to solve a range of problems. So that would include simple fraction and decimal place value problems. And pupils should draw with increasing accuracy and develop their mathematical reasoning so that they can analyse shapes and their properties and confidently describe the relationships between them. It should ensure that they can use measuring instruments with accuracy, like rulers, for example, and make connections between measure and number. So all the time, one part, the number part, is supporting the shape part, and the shape part of their learning is supporting and giving them opportunities to practice the number part. So by the end of year 4, pupils should have memorized their multiplication tables up to and including the 12 times table and be precise and fluent in their work. Obviously, not all children will manage to do this, but that's really what we're aiming for. And then finally, children should be able to read and spell mathematical vocabulary correctly and confidently, and using their growing word reading knowledge and their knowledge of spelling. Okay. So what will my child learn about? So there are 7 areas in the curriculum that children will learn about in year 4. And those are place value, addition and subtraction, multiplication and division, fractions, including decimals and percentages, measurement, properties of shape, position and direction, and statistics. And by statistics, we mean things to do with data and how you represent that data in graphs and charts and diagrams. Okay. So how does my child learn maths at Castlemead School? So we take a mastery approach at school, and that means that the learning should be achievable for all. We have high expectations and encourage a positive can-do mindset towards maths in all pupils, creating learning experiences which develop their resilience with challenges, and we scaffold the learning carefully so that everyone can take part in that process and everybody is able to access the learning. The learning should be deep and sustainable, so lessons are designed very carefully in little steps so that you secure each step before you move on, so everybody's confident with that. The learning and the teaching builds on previous learning, so again it's bit by bit, so supporting the children to feel confident with what they're doing. The children learn to reason about a concept and make connections. So the pupils are encouraged to make connections and spot patterns between different concepts. So really, if a child's really confident with their maths, they will have made those connections between different areas in their mathematics learning. And they will be able to use precise mathematical language. We're giving them lots of opportunities in the normal set of circumstances to do that. So by having lots of classroom discussion during lessons, and then also in their maths journals to write about their understanding and exploring each of the concepts. By doing this, children's working memory is freed up so that they have room to explore more challenging ideas and to develop their conceptual understanding, so their ideas of on their understanding of the concepts that are involved in each topic of maths that they learn about. Children develop conceptual and procedural fluency, so the concepts are to do with the understanding that goes on behind what they do with numbers, but the procedure is actually what they do with those numbers. So for example, writing an addition equation or adding 2 fractions together or something like that. So teachers move from one context to another using objects, pictorial representations, equations and word problems, and there are high expectations for pupils to learn times tables and key number facts so that they're automatic and have a true sense of number. And the stronger that sense of number that children have, the more successful they are likely to be. Children are also encouraged to think about whether their method for tackling a given calculation or problem is appropriate, reliable and efficient, so that they are not being passive in the process. So what you don't want is a child using a long, complicated equation when they could have done something quite simply in their head. The next part is about problem solving and how that is central to their learning, and that develops children's understanding of why something works so that they truly have an appreciation of what they are doing rather than just learning to repeat routines without grasping what's happening. And then finally, challenge through greater depth. So rather than accelerating the content and moving children into the learning for the following year group, what we do is to set tasks to deepen children's knowledge and improve their reasoning skills within the objectives of their year group. Okay. As part of the mastery approach, we use the CPA approach. So the C stands for concrete, so that's where we use objects and resources to manipulate to help children with their thinking. And then there's the pictorial stage where children use diagrams, images, drawings and models to represent their ideas and their thinking, and then finally using signs, symbols and digits. So there will be some crossover where children might use more than one of these at a time, and they might revert back to one when they're learning a new aspect of something. And this is a recognised progression in children's mathematical learning. So here are some examples from year 3 and year 4. So you can see on the left, children are using what we call DEANS, or base 10s resources to represent hundreds, tens and ones, where they're adding two numbers together. But it's within a frame which is supporting them with that. At the same time, then in the middle picture, you have got a child drawing a diagram which is related to that first example, but it's all pictorial representation. You've got a bit of abstract at the top, and then finally you've got the abstract representation as you would recognise it, the standard formation. So how can you support your child to be successful at maths? So helping your child to practice working out and remembering number facts will support them with other more complex and challenging mathematical procedures and concepts. As we said, it will help children to free up their working memory so they just can concentrate on the more complicated task, because they'll have this information automatically. They will have learnt it so well. That's what we're aiming for. So in year 4, we want children to know their number bonds to 10, 20 and 100. So that's pairs of numbers that go together. So for example, number bonds to 10 are like 8 and 2, 7 and 3, 6 and 4. Number bonds to 20, 16 and 4, 10 and 10, 5 and 15. Number bonds to 150 and 50, 25 and 75 and so on. Times tables facts to 12 times 12. Again, if you remember, that we're aiming for that for the end of year 4. We know some children won't get there, but that's what we're aiming for. And the process doesn't end at the end of year 4. We keep on practicing our times tables after that. So if we haven't got them, then we carry on. Doubles and halves of numbers to 100. That's really important and really helpful in all sorts of ways. Counting forwards and backwards in tenths. So like 0.1, 0.2, 0.3, hundredths, all right, 0.01, 0.02, 0.03. Fractions, so counting forwards in halves, maybe half, 1, 1.5, 2, 2.5, or maybe thirds, 1/3, 2/3, 3/3, or 1 whole, 1 and 1/3, 1 and 2/3, 1 and 3, or 2. Negative numbers, so being able to say, I count back from 3 to -10, 3, 2, 1, 0, -1, -2, -3, and so on. Multiply and divide numbers by 10, 100 and 1,000. A little word of caution with that. What we don't want children to say is, oh, you just add on a 0. If you take, that isn't actually mathematically correct, because the numbers are moving up one place, and the trouble is that when children then come to multiply decimal numbers, if you just stick a 0 on the end, it doesn't work. So they need to understand the concept. And so that goes back to what I was saying earlier about having that conceptual understanding. What's happening with, so if you were multiplying 4 by 10, it looks like you're sticking a 0 on the end, but actually the 4 is now becoming 10 times bigger. And so that 4 will now go into the tens column. It will represent 4 tens, and then the 0 will be used as a placeholder to show that there are no ones, and it will help the 4 to demonstrate that it's representing 4 tens. Welcome, Charlie Campbell's mummy. Could you just mute yourself, please? Thank you. Okay, so top tips for parents. So maths at home, if you can do anything at home to support your children, that's a really powerful thing to do. There's a great opportunity if you've got the opportunity. We realise that it's really difficult for you, particularly at the moment if you're trying to work from home, if you've got several children, if there's limited Wi-Fi availability, limited opportunity with devices. But if you do have the opportunity, it can make all of the difference. You can do all sorts of things like getting your child to help you find the best deal for your car insurance, or work out which supermarket deal is the cheapest. Getting them to understand how maths relates to real life. It also helps to develop their basic maths and problem solving skills, which are really important in the primary curriculum. Don't underestimate yourself. That's really important. You and that role modeling is so powerful. And getting involved in their learning if you can, it's so powerful. Ofsted have specifically stated that parental engagement raises pupil achievement. So there's evidence that it makes a difference. So some tips. So first of all, and perhaps most importantly, try not ever to let your child hear you saying, I'm really bad at maths, or I can't do it. You might think it, but try not to say it out loud. It's only a small thing, but your children can pick up on negativity towards subjects. And unfortunately, this can be a real barrier to their learning. So we advise parents to use positive language around your children when you're talking about maths. So you may not mean to be negative, but your children might take it to heart. So if you can be positive, then that will help your children to have a positive maths attitude, and will very likely help them to improve their outcomes in maths. If you have the chance, again, you know, we're living in the real world, so do what you can. But if you have the chance to play games together, you know, anything, it doesn't have to be specifically mathematical, but there are lots of games that have mathematical elements to them. Even jigsaw puzzles can help children to develop logical and spatial awareness skills. Board games with dice develop children's counting skills. Other games might help your child's math skills at darts, Scrabble, and chess. So try to learn the methods that your children are learning, rather than trying to teach them using methods that you learned in school, because that can be confusing to them. So if you can try to learn their methods, then that will help with continuity between the school and home. And I suppose it's all the more important at the moment. And I will share some website addresses with you in a moment, but and you might find those helpful with that particular aspect. But if there's anything that you're not sure of, then please do contact either myself or Miss Elliott, because either one of us would be very happy to help you with explanations of things. There are more and more digital clocks around now, and fewer analog clocks, so, you know, clocks with hands. So if you can try to make sure that your child practices reading analog clocks in everyday life, that is part of the maths curriculum still. That, you know, lots of children are very confident with digital clocks, but analog is still a thing, so we still need to teach it to them. So it could be something as simple as reading the clock that you walk past on the side of a building. Fractions could be simple for you to practice, just simple common fractions that you could practice at home, especially, you know, even if you're not very confident yourself, just stick to fractions that you know, like half or quarter. So you might see something split into 4. It could even be children's food. That's usually a classic thing. So talking about, you know, this one of 4 equal parts, I've split the pizza into, or the cake or whatever. How much is that? What fraction of the pizza are you having? Just make sure that the parts are all roughly about the same size. Because obviously one of the key points about fractions is that each part should be equal. Times table, so I've talked about that already, but it's really essential. So it's, you know, arguably an easy thing for you to help children practice with. and to sneak in when they're bored, perhaps during car journeys, or distract them at other times. If they're fed up with reciting them, you could maybe challenge them to recite them backwards. Problem solving. Again, I think I mentioned a moment ago, try to help them or encourage them to find the best deal at the supermarket, or how much their toys worth when there is a 40% sale on, or which internet provider has the best deal when you need to switch, something like that. And then playing to their love of technology. Again, you might feel that your children are spending enough time on their devices already, but if there's an opportunity, it can be useful. So giving children short bursts of online practice, and there's all sorts of maths apps and things. And as I said earlier, I'm going to share some websites with you in a moment that you might find useful for children to practice things like times tables and number bonds. Okay, so here are those websites. This this workshop is being recorded, so this list will be available in the recording, but also I'm planning to share it as a PowerPoint as it is, so you'll be able to access these details that way too. Okay, right, so let me just stop sharing for a moment and I will